Hello students. So for today's video or this particular video, we will be just revising the different cipher techniques we have studied. So I hope by this time now everybody is very familiar with the word cipher, cipher text, plain text, cryptography and all. So I hope you are aware of the different conventions also which we use when we are doing encryption. For example, whenever you are writing a plain text, you will be always writing with the small case letters. And when you are writing a cipher text, you will be always writing with the capital letters. So we started with the symmetric cipher model. And what do you mean by symmetric here? Whatever algorithm or whatever steps we have followed during the encryption, almost similar steps will be followed, or but in the reverse order when I am going for a decryption. Sometimes symmetric cipher model also suggests the key is the same for the encryption as well as the decryption. And I hope you remember we have stressed that encryption algorithm can be a public. Everybody can know how the plain text has been converted into the cipher text, but the more weightage or the more secrecy should be given to the key which is used. So key is the one where all secrecy lies. Okay. Cryptography, we have studied what does a crypto means, what does a cryptography means. It is nothing but where we study how to encrypt the text, and we also study how to attack those texts, or what are the different types of attack which are there in the study of this cryptography. So crypto analysis is nothing but where I have the knowledge of encryption algorithm. I can understand what are the technical terms in it. I can understand the technical definition which it has been mentioned. I can understand the technical specifications which has been mentioned, and I will use this knowledge of my crypto terms to attack a ciphertext. So when I say attack, that means given a ciphertext and given an encryption algorithm to me, but without a knowledge of key, I'm able to find out the plain text. So that is a crypto analysis where you have the knowledge of cryptography, you have studied the cryptography, or you are basically aware of the different encryption algorithm which are used. And then we have studied the brute force attacks also. So if you remember, we have carried out this brute force attack for a substitution cipher or a Caesar cipher, where a Caesar cipher you are just shifting a particular alphabet or a particular letter by a position of 3. So here what does a brute force attack means? It means as I know that substitution has happened, and then I try out all the possible keys. So what are my possible keys? Suppose I say I have, as I have always tell you to write it in the margin, you have written A to Z and then you have numbered it from 0 to 25. So a brute force attack says that whenever a ciphertext is given to me, I try out all the 26 possible combinations to find out the plain text. So what does it mean? Suppose a letter is given to me A, B, C, D. So I try replace A with Z, I try replace A with Y, I try replacing A with X, and so on. So entire ciphertext I go on replacing with all the possible keys. And at one particular point I can find out where is a meaningful sentence has been found out, or a English sentence has been found which makes certain sense. I will stop at that moment and I will say, okay, I have discovered a key, and this was the key which was used for a encryption. So brute force attack, it is a very basic attack which is carried out first, and you can implement this particular attack in the software also. So when I say software, we will be doing this particular attack in our lab also. So where we will try to find out all the possible, we will try to find out the output for all the possible keys. Now in the, when I say we will be try to implement in the software, remember this one thing, that the software will not tell you that this is the key. What it can give you idea is these were the keys and these were the possible output. So here human intervention is required. You will be reading out all those output, and then you will be finding out which particular sentence makes sense, because the machine will not understand. For machine it will be all alphabets and letters. Okay, so that is a brute force attack. And then we studied the transposition technique. So if you remember, the biggest difference between the transposition techniques is nothing but where you just reorder the letters. Okay, substitution cipher is you substitute or you replace the letter. So in the transposition cipher we have gone for a rail fin cipher, and then we have studied the row transposition cipher. So railfence, if you remember, uh, just give me a moment where if I can change a pointer color. Yeah. So in the rail fence, suppose I will write in a zigzag manner. So I will write my plain text in zigzag manner like this. So this is called as a rail fence of a depth 2. So I'm writing in 2 rows. And when I'm reading this text, I'll be reading it row wise. So my cipher text will be A, C, E, B, D, F. That is my rail fence cipher. When I'm talking about row, here I will write the plain text in a single row, and the columns will be decided by key. Okay, so suppose whichever number is maximum in the key, suppose I write 2 3 4 5, so 5 is the maximum number, so I should write this particular plain text in the column of 5. So I write this way for the row, and according to the key the columns are arranged. I can rearrange the column and then the cipher text is formed. So a transposition technique, you can go on increasing the complexity. So for the transposition technique, we have seen the encryption as well as the decryption, how it is done, how to find out the key once the encryption key is given to us. Okay. Then we have substitution technique, in which we studied Caesar cipher, where the shift is always a 3. That is, I'm shifting every alphabet ahead by 3 letters. Then you have monoalphabetic cipher, where I will try to find out if I can uh, a keyword will be decided by me, and then the letters will be shifted. Then I had playfair cipher. So playfair cipher is nothing but a keyword will be given to me, and then I will be writing those keyword in terms of 5 by 5 matrix. And here I will always take 2 letters of together, and then I will be doing the encryption. Then we have Hill cipher. So you can view this particular video whenever you want to revise these cipher techniques. So Hill cipher is nothing but where I write key is in terms of matrix. So I will write down numbers here, and then it will be multiplied with the plain text, and then you will get your cipher text. So here the mathematical calculations are required. Polyalphabetic ciphers again, if you remember, it is Wiener cipher, which a very huge table was given where all ABCD was written here. That will be formed as a key, and then you write here as a column the plain text. So and you pick out a letter depending upon the key here. So polyalphabetic ciphers, also Wiener ciphers and all we have studied. Then there was a one-time pad which said that the key will be generated only once, and it will be randomly generated. So once it is used, the key is destroyed. So it is very difficult to decrypt this kind of ciphers, or it is very rare possibility that once you are using any random generated algorithm, it will generate the same numbers. Then you have steganography. So steganography, when we started, I have already told you the difference between cryptography and steganography. The main science or the main idea behind steganography is you want to hide the message. You are saying that nobody should come to know that we have hidden a certain message, whereas in the cryptography, the encrypted message is known to everybody. It is very public. But steganography, you use certain technique like invisible ink, or message in the paragraph. So we have seen I think 2 or 3 examples related to the steganography. So I hope all these things are very clear to you, and you are able to recollect whatever has been taught to you in the previous videos. So there were 2 websites which I would like to we will be visiting in this video also, and then I want you should note down these website, and you can try out numerous examples on that particular website. You can just play with those particular things and understand more about the ciphers. So now see this particular website. So in this wheel, if you see here it is written type a secret message, and you have a shift key here. Okay, so this is your key which is written in an inner circle. And in this particular example, enjoying. Okay, so now see, A is replaced by G, R is replaced by, let us find out, travel to this wheels, yes. So R is replaced by K, sorry, R is replaced by X. Then you come to you remember this outer wheel is your plain text, inner wheel is your key. So you can go on trying different examples. You can find out, when I told you that A, it follows a modulo 6. So let us write X, Y and Z. Okay, so plain text is X, Y, Z. So if you see here X, it is replaced by D. After T, once it is the key is Z, it will again start with A, B, C, D. So you can try out different examples, work with this, or when I give you a certain text to do the shift cipher or substitution cipher, you can cross check your answers here. What you have to remember, you have to choose a letter. You don't go on this numbering. Okay, so this was related to your Caesar cipher. Remember, Caesar cipher, normally we say that shift is 3, but again it is a substitution cipher, so any number of uh, shifting is also referred as Caesar cipher. But if it is not mentioned what is the shift, please assume that the shift is 3. Now let me go to the another website and show you. So this is a fingerprint analysis. Now what do you mean by fingerprint? If you remember, I had told whenever we write in English language, it has a certain pattern. What do you mean by pattern? There are few alphabets, few letters, few words which are repeated in the English literature. So whenever you write a plain text, it will show you what is the pattern which you are following. So suppose I write anything, so it will give me a analysis that in your plain text a particular alphabet has occurred this number time or occurred maximum time. In your plain text, which alphabet has not occurred frequently. So this is called as a fingerprint analysis. So let us write something and find out. I will write the same letter, same sentence. Are you enjoying? Okay, so see here, I don't know if you are able to see, A is this pattern E. So now when I see here this particular plain text, it is not giving me a particular, I mean a maximum distribution of letter. That means I cannot find out which letter is having a maximum, because I have used many of the most of the alphabet and very few alphabets are repeating here. So sometimes instead of plain text, you can include here cipher text also. So what will happen, you can find out in the cipher text which letter is occurring maximum time, and then you can map it to your English language analysis. So instead of writing plain text, it is better if you write a cipher text here and find out what is the fingerprint you can get. So remember, fingerprint is nothing but it is just finding out, doing an analysis of alphabet wise or a letter wise. You can also develop your own graph where you write down the you do the analysis based on 2-letter words or 3-letter word. For example, th or a the, like the, if you're going for a 2-letter word, it can be is, that is true. And so these are the most frequent words which happen in the English language. So if I type a cipher text here, you can easily find out which 2 letters has occurred frequently, and then you can map it to your English language. So I hope you do visit these websites. I'm not promoting this particular person or a particular organization, but I found that it is really helpful if you try out different example with this particular website. So I hope things are clear in this particular video, that we started with the recap and you are able to recall whatever things we have covered in the previous lecture. So let's hope that you are now thorough with this particular cipher techniques, and we can move ahead to the next topic in the next video. Thank you.
For over 400 years, the problem remained. How could Alice design a cipher that hides her fingerprint, thus stopping the leak of information? The answer is randomness. Imagine Alice rolled a 26-sided die to generate a long list of random shifts and shared this with Bob instead of a code word. Now, to encrypt her message, Alice uses the list of random shifts instead. It is important that this list of shifts be as long as the message as to avoid any repetition. Then she sends it to Bob, who decrypts the message using the same list of random shifts she had given him. Now Eve will have a problem, because the resulting encrypted message will have two powerful properties. 1. The shifts never fall into a repetitive pattern. And 2. The encrypted message will have a uniform frequency distribution. Because there is no frequency differential, and therefore no leak, it is now impossible for Eve to break the encryption. This is the strongest possible method of encryption, and it emerged towards the end of the 19th century. It is now known as the one-time pad. In order to visualize the strength of the one-time pad, we must understand the combinatorial explosion which takes place. For example, the Caesar cipher shifted every letter by the same shift, which was some number between 1 and 26. So if Alice was to encrypt her name, it would result in one of 26 possible encryptions. A small number of possibilities, easy to check them all, known as brute force search. Compare this to the one-time pad where each letter would be shifted by a different number between 1 and 26. Now think about the number of possible encryptions. It's going to be 26 multiplied by itself 5 times, which is almost 12 million. Sometimes it's hard to visualize. So imagine she wrote her name on a single page, and on top of it stacked every possible encryption. How high do you think this would be? With almost 12 million possible 5-letter sequences, this stack of paper would be enormous. Over 1 kilometer high. When Alice encrypts her name using the one-time pad, it is the same as picking one of these pages at random. From the perspective of Eve the codebreaker, every 5-letter encrypted word she has is equally likely to be any word in this stack. So this is perfect secrecy in action. A strong cipher is one which disguises your fingerprint. To make a lighter fingerprint is to flatten this distribution of letter frequencies. By the mid-15th century, we had advanced to polyalphabetic ciphers to accomplish this. Imagine Alice and Bob shared a secret shift word. First, Alice converts the word into numbers according to the letter position in the alphabet. Next, this sequence of numbers is repeated along the message. Then each letter in the message is encrypted by shifting according to the number below it. Now she is using multiple shifts instead of a single shift across the message as Caesar had done before. Then the encrypted message is sent openly to Bob. Bob decrypts the message by subtracting the shifts according to the secret word he also has a copy of. Now imagine a codebreaker, Eve, intercepts a series of messages and calculates the letter frequencies. She will find a flatter distribution or a lighter fingerprint. So how could she break this? Remember, codebreakers look for information leak, the same as finding a partial fingerprint. Anytime there is a differential in letter frequencies, a leak of information occurs. This difference is caused by repetition in the encrypted message. In this case, Alice's cipher contains a repeating code word. To break the encryption, Eve would first need to determine the length of this shift word used, not the word itself. She will need to go through and check the frequency distribution of different intervals. When she checks the frequency distribution of every 5th letter, the fingerprint will reveal itself. The problem now is to break 5 Caesar ciphers in a repeating sequence. Individually, this is a trivial task, as we have seen before. The added strength of this cipher is the time taken to determine the length of the shift word used. The longer the shift word, the stronger the cipher.